Packets of chips sure are a yummy treat, but they can also make you pretty thirsty.
And you're left with an empty packet at the end.
So we developed a way to recycle them and purify the water at the same time.
We're engineering students from the University of Adelaide, and today we're going to show you how to use this common waste product to make clean water. Here in Australia, our water supplies are treated at huge facilities with modern technology, and we can be sure the water that comes out of our taps is clean and safe.
But in countries like Papua New Guinea, clean water can be a bit hard to find. So we wanted to create an easy and cheap way to get rid of any nasty germs that might be lurking in our water supply. We decided to use a system called solar disinfection. This just means that radiation from sunlight kills the germs and cleans the water.
And here's what we came up with. You can see a large cylinder lined with chip packets and a glass tube in the middle. To use it, we simply feed water into the tube. The curve of the cylinder is set precisely so that the sunlight is reflected by the metallized inner layer of the chip packets towards the center, right onto the tube.
This concentrates energy from the sun so much more radiation can hit the water. As the water flows along the tube, the concentration of UVA radiation reacts with the water to kill any pathogens.
By the time the water flows through the end of our system, more than 99.9% of the germs have been killed, easily making the water safe for drinking. This size system can clean 10 litres of water every single hour, and users could add as much glass tubing and chip packets as they needed.
All of the materials to make a water purifier like this only cost $67, making it perfect for people living in poverty. We're making the plans for this available to anyone all over the world, and we would hope that people living in rural communities will find plenty of use for it.
So just because you're finished with the chips,
It doesn't mean you have to be finished with the packet.
From a novel use for a chip packet to designing cooking to be cleaner and greener. Here's part 2 at our look at clever solutions for developing countries.
Hi, I'm Oliver.
I'm Alexis.
And I'm James, and this is our engineering project. Do you think we A, measure how much it grows, B, light it on fire, or C, chop it in half? If you chose light it on fire, you're absolutely correct. This is our cook stove, and we'll be showing you how we experiment with it today. Unlike the modern ovens found in most Australian homes, people who live in developing countries depend on smaller devices called cook stoves.
These work pretty well, but they can emit harmful gases and sometimes they aren't very efficient. So we're using this version to try and come up with a better solution.
To make it work, we simply put fuel in the column. We use wood chips, but it could be any similar natural material, and light it up.
We can change certain features of the stove, like where the fuel sits and how much air can flow through the stove.
Let us show you what this means, starting with adjusting the fuel. You might have noticed that on a campfire, the flame sits right on top of the wood, which is like our fuel. But in our test, the flame actually sits above the fuel. This might seem a little strange, but it's because of the way things burn. This is called combustion, and as the fuel is heated, it releases volatile gases. It's these gases that burn. You can see this really clearly in another one of our tests. Watch for the white smoke that disappears.
Now let's see how changing the airflow affects how the stove works. We add a special chimney so we can adjust the amount of air that flows in. More airflow means more oxygen and a larger amount of combustion. So basically a bigger fire. This is useful because it burns the fuel more efficiently and it creates less harmful emissions.
We hope that by fine-tuning these factors, we can make better stoves for the people who need them. At the moment, we suggest that people using cook stoves should let more air in through the middle and sit their fuel close to the top. But in the meantime, we have plenty more variables to test. But I must admit, it was pretty fun setting our experiment on fire.